Today, I'm gonna look at something simple, like some modern game like Cry Primal. I have a couple of examples of models extracted. They even have names, which is very convenient. This one is some kind of mammoth, probably dead one. Let's see what's inside. We have some count of materials here, some kind of table, LOD list, and then it's probably geometry data. It really looks like geometry data. It's long, and these numbers look like that. Alright, so if we scroll down a bit, we can see after some time it changes to a face data. These look like faces, especially in this part. You can see this 2E repeating every 2 bytes. Like then after that, that's probably next LOD, which will be smaller, next face part, and it continues. So let's return to the first LOD here. Oh, this is LOD's part probably of this file, some kind of table. And here, somewhere around here, the vertices data start. So let's measure that from here to somewhere around here where faces start. The whole vertices part will be about 77DC0. Now let's see the size of each vertex data. Notice that FFFF, that's probably they repeat, and it looks like one vertex data will be like 20 bytes in hex. We don't know exactly which vertex, where it starts and where it ends. We know only probably a size of one vertex data. Sometimes it's easier to look at the beginning, sometimes at the end. In this case, probably no, we don't know. All right, so let's return to the beginning. And we had something like, now this 770A0 looks really like the size of a whole vertex buffer. Well, and if we divide that by 20 hex, we'll get a count of vertices, 3BED, which is really actually here. And this 3BEC is -1. So this is probably a count of vertices in our model, and that's vertices data. So let's go to faces now. They start about here probably, and let's see how long they go. Somewhere about here. Yeah, somewhere about here. These are E6D6 bytes, and each index is 2 bytes. Like this must be a number of face indices here in this model. So we can return to the beginning of faces data and see this number here. This is exact number because it's usually clear when face indices start. Okay. So we have vertex count and face indices count. And as many modern games is just like you get vertices, you get face indices, you connect them, and that works. Because if you go looking at these indices, you can see they increase 2, 3, 4, 5, and then up to some high numbers going somewhere around 34 or something. And remember, we have 3BED vertices. That means that it can actually work, because the whole face buffer probably includes all vertices, and that means we don't have submeshes. We have only one big mesh which connects all these vertices with all these face indices. Let's see if it can work. But before that, we need to convert vertices somehow, because we don't know where to start and where is the x, y, z coordinates here. So let's go we can't be sure where it starts. This is a size, and this we don't know where it starts. So let's go to the end of this. And you know, this is a face indices count. Right before that, this is probably the very last vertex. And that's the size 20 bytes in hex. So this can really be x, y, and z must be here, but I don't see any float numbers here. So that would be even easy, because you can always see float numbers. But in this case, it's probably integers, like short, like 2-byte integers. That happens sometimes. And probably in this case, this is x, y, and z. And this one is probably scale, which is always 1, 1, and 1. So maybe if we try building this as x, y, and z and connect them with these face indices, this can work. Let's see. Well, this really looks like it. That's some kind of a dead mammoth. Probably partially eaten already, and that's its fur and all the parts. Well, alright, so that's only one mesh. That's the easiest format of model, probably, which has only one mesh, and it's easily connected. Now, if we return to the beginning of face buffer and look at this table before the vertices, this number of vertices, then 7, then some numbers increasing. This looks like a submesh table, like 7 submeshes, but in this case, these are probably just materials list, because the whole mesh can be converted without that. And this A96B something, these increasing numbers are probably just number of face indices where materials split, like the first material goes from 0 to that, then next one, and then we must have 7 materials. We can read this table and parse this and try to split all the faces in the model into materials. And let's see how it can look like. Okay, we got 7 parts, and I already make them named manually, and we have some bones, a part of body, head, some part that probably damaged, and more inner parts, and then the forehead and fur for the body. And they really look like 7 submeshes for materials for this mammoth. And that's probably it. That's all. That very easy model format. And now we can go back and look for the first part, see what we have here, how to parse these materials and everything, to find the UVs and normals and all the other parts here. And this one is probably, it has no bones because it's dead, but the other models will have skeletons too. But this is what we can do just in 10 minutes. A very simple format. And now we have a model from Cry Primal converted. That's all for today. Thanks for watching.